As one last example of force diagrams, let's go back to the situation we dealt with in the friction lab. So during this lab, you were dragging a block across the table at a slow, constant velocity. And we said that this was important, that it was dragging at a constant velocity, and now let's show why as we go through the force diagram for this. So because we are dragging this along at a constant velocity, one thing we know is that when velocity is constant, the velocity is not changing. This tells us that the acceleration in this case is equal to 0. This is a key point because what that means is when we draw the net force diagram, there is no net force. When an object is not accelerating, it has no net force on it. This is going to be really helpful for us as we start to think about the individual forces. So let's go back to that now. In this lab, we knew that we dragged along in the first case with a rubber band as shown on there that was attached to the hook. And as I've shown by the arrow at the top, I'm dragging this to the right, which I have defined as the positive direction. The rubber band grabbing the hook and pulling it that way is exerting a force on the block. So we know that there is some force going to the right in this case. And we can see that comes from the rubber band. What was asked in the lab was whether there would be any other horizontal forces acting on this block. Because we're only concerned with the horizontal forces, we don't have to worry about the table pushing upward. We don't have to worry about gravity pulling it downward. Nothing like that. We just need to think about whether there should be any other force acting left or right for this thing. This is where it's important that we had no acceleration and therefore no net force. Because there is no net force, any force in the horizontal direction must be canceled out by another force going the opposite way. In this case, since our rubber band is shown as exerting a force pulling the block to the right, there should be another force pulling it to the left. We don't necessarily know what this force is, and we did not when we were going through this lab, so we called it just some force. And we don't need to know what it is. All we need to know is the fact that because there's no acceleration, there must be some other force pulling backwards. This is just a consequence of what we talked about with forces combining together to generate the net force on the object. One other thing about this is that we know that the magnitudes of the two forces should be equal. Even though we are dragging the block to the right, because it's not accelerating, the two forces must exactly cancel each other out. That means that the rubber band must be exerting an equal force to the force that was pulling it in the opposite direction. We don't even need to know what is exerting this force. This is just a consequence of adding those two forces together to find that there is no net force acting on the object. As we went on later, we see that this is the friction force. And so then that tells us something more about what the force is actually about. But we got all the answers that we need to know about its size and direction just from working with this force diagram.